Hi everybody and welcome to Operating System Security. Let's begin. Every day you use a smartphone or a laptop or almost any type of computer, you interact directly or indirectly with an operating system. Operating systems include Microsoft Windows, Mac OS, iOS, Android, Chrome OS, and Linux. But what is an operating system? To define an operating system, we need to visit one computer term: hardware. Computer hardware refers to all the computer parts and peripherals that you can touch with your hand. Hardware includes the screen, the keyboard, the printer, the USB flash memory, and the desktop board. As shown in the figure below, the desktop board contains many components, in particular a central processing unit, CPU, and memory chips, RAM. Although not shown in the image below, the desktop board is usually connected to a storage device, HDD or SSD. The desktop board is the main part of a computer, and all the other pieces of hardware from keyboard and mouse to screen and printer connect to it. However, hardware components by themselves are useless if you want to run your favorite programs and applications. We need an operating system to control and drive them. The operating system, or OS, is the layer sitting between the hardware and the applications and programs you are running. Example programs you would use daily might include a web browser such as Firefox, Safari, and Chrome, and a messaging app such as Signal, WhatsApp, and Telegram. All the programs and applications cannot run directly on the computer hardware. However, they run on top of the operating system. The operating system allows these programs to access the hardware according to specific rules. Some operating systems are designed to run on laptops and personal desktops, such as Microsoft Windows 11 and Mac OS. Other operating systems are designed specifically for smartphones, such as Android and iOS. There are also operating systems intended for servers. Examples include Microsoft Windows Server 2022, IBM AIX, and Oracle Solaris. Finally, there are operating systems that you can use on a personal computer and server. One example is Linux. The image below shows the popularity of the different operating systems used to browse the internet according to StatCounter, based on the data collected during January 2022. Okay. Your smartphone might be running Android or iOS, and you might have plenty of private data on it. Examples include private conversations with your family and friends, private photos with family and friends, email client that you use for personal and work communications, passwords saved in the web browser or even in notes, and e-banking apps. The list of confidential and private data goes on. You don't want someone you don't trust to open your phone and go through your photos, conversations, and apps. Hence, you need to secure your phone and its operating system. The same goes for your laptop or computer running Microsoft Windows, Mac OS, or Linux. Your computer will most likely contain plenty of information, such as confidential files related to your work or university, private personal files such as a copy of your ID or passport, email programs such as Microsoft Outlook and Mozilla Thunderbird, passwords saved in the web browser and other apps, and copy of digital camera and smartphone photos. The list can get very long depending on the type of user. And considering the nature of the saved data, you want to ensure that your data is secure. When we talk about security, we should think of protecting three things. Confidentiality. You want to ensure that secret and private files and information are only available to intended persons. Integrity. It's crucial that no one can tamper with the files stored on your system or while being transferred on the network. And availability. You want your laptop or smartphone to be available to use anytime you decide to use it. Okay, and now we get to the question here. Which one of the following is not an operating system? And that will be Thunderbird. Okay, so we type in Thunderbird. All right, and now we can move on to the next task, which is common examples of OS security. Let's see. As we mentioned in the previous task, security is concerned with attacks against confidentiality, integrity, availability. In this room, we will focus on the 3 weaknesses targeted by malicious users: authentication and weak passwords, weak file permissions, and malicious programs. Authentication and weak passwords. Authentication is the act of verifying your identity, be it a local or a remote system. Authentication can be achieved via 3 main ways: something you know, such as a password or a PIN code; something you are, such as a fingerprint; something you have, such as a phone number via which you can receive an SMS message. Since passwords are the most common form for authentication, they are also the most attacked. Many users tend to use easy-to-guess passwords or the same password on many websites. Moreover, some users rely on personal details such as a date of birth and name of their pet, thinking that this is easy to remember and unknown to attackers. However, attackers are aware of this tendency among users. The National Cybersecurity Center, or NCSC, has published a list of the 100,000 most common passwords. Let's look at the top 20 passwords in the table below. Okay, and here they are. Okay, now we can see that 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, etc., are on the list. Yes, we can see that right here, of course. Dictionary words such as password, I love you, monkey, and dragon are commonly used. Words not in the dictionary include the letters that you see here, the letters that you see here, and the numbers and letters that you see here, right? These seemingly complex passwords are very predictable as they follow the keyboard layout, as we can see in the image here, or the GIF file. Okay, in brief, if the attacker can guess the password of any of your online accounts, such as your email or social media account, they will be able to gain access to your private data. Therefore, it is vital that you choose complex passwords and use different passwords with different accounts. Weak file permissions. Proper security dictates the principle of least privilege. In a work environment, you want any file accessible only by those who need to access it to get work done. On a personal level, if you are planning a trip with family or friends, you might want to share all the files related to the trip plan with those going on that trip. You don't want to share such files publicly. That's the principle of least privilege, or in simpler terms, who can access what. Weak file permissions make it easy for the adversary to attack confidentiality and integrity. They can attack confidentiality as weak permissions allow them to access files they should not be able to access. Moreover, they can attack integrity as they might modify files that they should not be able to edit. Access to malicious programs. The last example we will consider is the case of malicious programs. Depending on the type of malicious program, it can attack confidentiality, integrity, and availability. Some types of malicious programs, such as Trojan horses, give the attacker access to your system. Consequently, the attacker will be able to read your files or even modify them. Some types of malicious programs attack availability. One such example is ransomware. Ransomware is a malicious program that encrypts the user's files. Encryption makes the file or files unreadable without knowing the encryption password. In other words, the files become gibberish without decryption, reversing the encryption. The attacker offers the user the ability to restore availability. That is, regain access to their original files. They would give them the encryption password if the user is willing to pay the ransom. Okay, and now let's answer the question. Which of the following is a strong password in your opinion? Well, in my opinion, the strong password would be learn more. Okay, so learn more like this, and we submit, and we are right. And let's move on to the last task, which is practical example of OS security. Okay, let's see. In one typical attack, the attacker seeks to gain access to a remote system. We can accomplish this attack by tricking the target into running a malicious file or by obtaining a username and a password. We will focus on the latter. After discovering a username, we will try to guess the password. Furthermore, we will try to escalate our privileges to a system administrator. This account is called root on Android, Apple, and Linux systems. While on Microsoft Windows systems, this account is called administrator. The account's root and administrator have complete, unrestricted access to a system. In this task, we will try to hack into a Linux system. We assume that you have never used a Linux system before, and we will explain accordingly. Start the attack box by clicking on the blue Start Attack Box button at the top right of the room. Okay. Let's see. Start the attached machine by clicking on the green Start Machine button at the top right of this task. Okay, Start Machine. There you go. Now let's see. Oh, here we are. It usually takes a minute or two to load fully. Okay, once they are both ready, you should use the attack box, which should be taking the right half of your screen by now, and that is correct. On the attack box, start the terminal by clicking on the terminal icon shown in the image above. You will be writing all the commands you need on the terminal shown below. Okay. We will cover the following Linux commands and explain them throughout this task. So whoami, SSH, ls, cat, and history. We were hired to check the security of a certain company. When we visited our client's office, we noticed a sticky note with two words, Sammy and Dragon, on one of the screens. Let's see if Dragon is Sammy's password on the target machine. From the attack box terminal, we will try to log into Sammy's account by executing SSH Sammy at the IP address that we see right here, right? The remote system will ask you to provide Sammy's password, which will be Dragon. The interaction on the attack box terminal is shown below. Okay, so let's begin. So SSH Sammy at, and then we type in the IP address, right? So then 10.10.83.11 and enter. And now they ask us for the password, which we think is Dragon. Okay, so we type in Dragon like this. And by the way, we are not able to see the password being typed on the screen. But don't worry, nothing is wrong. Just type it in and make sure that the spelling is right, and then press enter. Okay, so now I already typed it in, and now I'll press enter. And now we are inside. Perfect. Okay, so let's continue reading and see what more we need to do. So amazing, it worked. Let's confirm that we are logged in as Sammy using the whoami command, which should return Sammy. Okay, so let's go back inside the terminal and type who am I? So we are logged in as Sammy. Perfect. So let's continue. To list the files in the current directory, we can use ls, short for list. This command will show all the files in the current directory unless they're hidden. So we go back inside in the terminal and type in ls and let's see. Okay, so we can see that we have 1, 2, 3, 4, 5 files, different files, some images, some text files, and so on and so on. Perfect. If you want to display the contents of any text file, you can use the command cat and the file name, right? Cat is short for concatenate. This command will print the contents of the file on the screen. In the terminal below, we see the usage of the 4 commands ssh, whoami, ls, and cat. Please follow along from the attack box's terminal. In our brief introduction to Linux, the last command that we will cover is history. This command prints the commands used by the user. We have learned about 2 other usernames that can access the attached machine. They are Johnny and Linda. We know that both of these users have little regard for cybersecurity best practices. We can use several ways to guess the passwords for these 2 users. Here we list 2 approaches. If you're not logged in as Sammy or any other user, you can use SSH Johnny at, and of course the IP address, and manually try one password after the next to see which password works for Johnny. If you're logged in as Sammy, which we are, or any other user, you can use su-Johnny and manually try one password after the next to see which password works for Johnny. And now let's start with the first question. Based on the top 7 passwords, let's try to find Johnny's password. What is the password for the user Johnny? So we can try to log in as Johnny. So for that, you just go back in the terminal and you type in su hyphen and then Johnny. Let's see, Johnny like this. Now we are asked for the password and we can try the first one. We can start with number 1. So 1, 2, 3, 4, 5, 6, and we press enter. And let's see. Nope, that is the wrong password. So we try again. So we log in, try to log in again as Johnny. We press enter. We are asked for the password and now we can try the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9. I press enter. And it's a failure again. And now, because I don't want to waste time, I'll just try number 7 because I know that's the correct password because I've finished this room a while ago. So we'll try to log in as Johnny again. So we type in su hyphen and Johnny. And this time I'll just type the right password, which is ABC123. ABC123, and I press enter, and now we are logged in as Johnny. Perfect. So let's answer the question. Go back to task number 3, scroll down and answer the question, which was, what is the password for the user Johnny, which is ABC123, and we submit, and we are right. Perfect. Okay, on to the next question. Once you're logged in as Johnny, use the command history to check the commands that Johnny has typed. We expect Johnny to have mistakenly typed the root password instead of a command. What is the root password? Okay, so let's do that. So we go back in the terminal, we type in history and enter, and let's take a look. And there you have it. This is the answer. This is the password. So I'll just type it in right here. Happy hacking like this. And we press submit. And we are right once again. And now to the last question. While logged in as Johnny, use the command su root to switch to the root account. Display the contents of the file flag.txt in the root directory. What is the content of the file? Okay, so we go back in the terminal, we type in su hyphen and then root. We are asked for the password. Then we type the password right here, which is going to be happy, and then capital H, let's see, and capital G, and enter. And now we have switched to the root account. And now let's display the contents of the file called flag. So we type in cat and then flag.text. And what happens is that we get our flag, right? So let's type that in here. So THM, curly braces, and then we type in you got root. Awesome. Like this, and we submit, and we are done with this room. Okay guys, thank you for watching. If you enjoyed the video, found it helpful, please give the video a thumbs up. I would really appreciate it. And of course, subscribe to the channel for more videos on TryHackMe. Okay, talk to you next time.